This program is brought to you by the Ministry of Education and Vocational Training Zanzibar in collaboration with Good Neighbors. The program is funded by KOICA.
Dear listener, you may learn so useful issues in this program as far as you will pay your attention to listen. However, our program today is specially for Form 3 physics learners. Self-assessment is allowed while the program is going on. Self-assessment is allowed while the program is going on. For our lovely teachers, the program will help you to prepare simple lessons for your students so that they will learn with joy and improve their performance.
Happy, 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 radio class. Happy, 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 radio class. Happy, 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 happy,
Oh, Musa, how are you?
I'm fine, thank you. How about you?
I'm very fine.
Are you cooking or watching TV?
Both. Actually, I'm preparing tomatoes, onions, potatoes, and lime while watching this movie. And when it finishes, I'll move to kitchen.
All right. Look at the knife in the jug of water, please.
I see it. What's wrong with it?
Something strange is happening to it. Don't you see?
No. What is it?
Wait. I'll take it out of the jug of water and then put it back in. Watch it carefully.
Wow. This is amazing and very interesting too.
Yeah, the submerged part of knife looks bending, isn't it?
Yes, it is. Now let me put the lime into the water.
Wow, the lime looks bigger, and this is virtual image of lime.
Yes. If it's a virtual image, then this is a reflection of light.
No, I think this is a more than one reflection of light.
Why not?
Because when a ray of light approaches a smooth polished surface and the light ray bounces back, it is called a...
Oh well, that behavior is called what? That is reflection of light.
I'm not sure. Let's find out.
Can you bring a torch, please?
Yeah, sure. Just a moment, please.
Okay.
Can I ask you a question, please?
Yes, you can. Why not, Musa?
Okay. Have you observed the bottle of water in front of the written letters?
Yes, I see.
And do you see the block of transparent material on top of the written letters?
Yes, I have observed one day at home. The written letters appear to rise up and magnified. Then?
This should take a couple of minutes. Are you ready to know more about this?
Yes, Musa. It is important to know. Come on.
Okay. Now switch on the torch and direct the light to the jug. Watch the rays of the light carefully.
All right. Now I know what you mean. Some rays of light reflect back, but others have gone through the glass jug of water and seem to bend toward the normal.
Yes, we know that light travels along a straight line in a transparent medium.
Can you remind me on the term transparent medium, please?
Okay. Transparent medium is a material which allows the light to pass through it totally. Transparent medium is a material which allows the light to pass through it totally.
Wonderful, Musa.
Thank you.
You have said that transparent medium is the material which allows the light to pass through it totally.
Are you satisfied with the answer?
Yes, but just a little bit. Could I have the example of the transparent medium, please?
The good example of the transparent medium are the glass block, bottle with water, lenses, and so on.
That's right. But here it seems light has traveled from one transparent medium to another transparent medium.
Sure. And look here. Some of the light reflects back after hitting the glass jug, while some pass through the other medium, which is water.
It is true. These light rays seem to bend. When the light bends, it is a certain behavior of light. This behavior is known as...
I'm just waiting for your response, please.
This behavior is called as refraction of light.
Good thinking, Salma. And therefore, refraction is the process by which the direction of a ray of light changes as it passes obliquely from one medium into another. Refraction is the process by which the direction of a ray of light changes as it passes obliquely from one medium into another.
Okay, let me say it. Refraction is the process by which the direction of a ray of light changes as it passes obliquely from one medium into another.
Salma,
Yes,
switch the torch off, then back on. I want to see something.
I know.
When the medium in which the light is traveling through is changing, the speed of light also changes. Do you know why?
Yes, Musa. This is because different medium have different optical densities.
It's true, because light traveled very fast through the air medium, but it slowed down when traveled through the glass medium. Light traveled very fast through the air medium, but it slowed down when it traveled through the glass medium.
Do you know why light travels very fast through the air medium, but it slows down when traveled through the glass medium?
Oh, no, I'm very sorry. Please, could you tell me the reason behind?
Okay, this means that the glass is high optical density than air, meaning that the glass is denser than air.
Exactly. And the optical density of a medium is therefore determined by the speed of light in that medium. And the optical density of a medium is therefore determined by the speed of light in that medium.
Good observation, Musa.
Thank you.
I agree that the optical density of a medium is determined by the speed of light in that medium.
Yes, the lower the speed, the higher the optical density.
Do you know? This shows that the two medium must be of different optical densities for reflection to occur.
Wow, good thinking, Salma. Is the first ray of light through the medium called the incident ray, like in the reflection of light?
Yes, the ray of light through the first medium is called as incident ray.
Uh-huh.
And that ray through the second medium is called the reflected ray instead of the reflected ray.
Sorry?
The ray through the second medium is called the refracted ray instead of the reflected ray.
I think so too. That's the ray through the second medium, the refracted ray.
Exactly.
Please, Salma, can we draw the normal line here at the point of incidence?
Sure. A normal line can be drawn at the point of incidence.
Okay, so
So, this angle between the incident ray and the normal at the point of incidence is called the angle of incidence.
if that's so, then this angle here between the refracted ray and the normal at the point of incidence is called angle of refraction.
Okay, the angle of refraction is between the reflected ray and the normal at the point of incidence. The angle of refraction is between the refracted ray and the normal at the point of incidence. Musa,
Yes?
can I take a protractor so that we can measure the angle of incidence and the angle of refraction?
Sure, but we also need a ruler, paper, and a pencil.
Do I also need to bring a rectangular glass? Or will this piece of home mirror be enough for the activity?
If you can find a rectangular piece of a glass block, it will be perfect.
Alright, I'll be back in a minute.
Soma, soma mwana soma, uwe mjini. Soma, soma mwana soma, uwe kijijini. Soma, soma mwana soma, ukiwa na mahitaji maalum. Soma, soma mwana soma.
Oh, very good. You got everything. That's great, Salma.
Thank you.
Now, we need a dark room to be able to see the reflection of light clearly.
Okay, can I close the windows as well as all curtains and switch off the lights?
Well, but you prepare the materials. I will help you close the windows.
Thanks.
Switch off the lights and TV, and when everything's ready, switch on the torch.
Musa,
Yes?
I had the rectangular glass block on the paper, ruler, protractor, a pencil near me, and a torch in my hand.
Alright. Now, we need to draw lines round of the rectangular glass block, then remove it from the paper.
Okay, it's ready. And now we have a drawing of rectangle. I think we should make a point on the upper line of rectangle through which we want our light to shine.
Yeah, that's good. Now, I'm switching off the lights and the TV. And you switch on the torch, please.
I think I should now draw the normal line through at the point which our light is passing through. Is that the point of incidence?
Yes, that is a point of incidence. Well done. Now, put the glass block back to the rectangle drawn.
Wow, it's amazing how light is refracting, isn't it?
It is indeed. I see the angle of incidence and the angle of refraction.
I see them too, but I also see the partial reflection of light, and it seems that the angle of incidence is not the same as the angle of refraction.
Yes, they are not the same. Now, remove the glass block and let's measure the angle using protractor. Can you do that?
Okay, I'm putting the protractor with 0 on a normal and being to measure the angle of incidence.
Good. The angle of incidence is 45 degrees. Let me measure the angle of refraction.
Okay, here is the protractor. Let us measure.
The angle of incidence is 30 degrees and the angle of refraction is 20 degrees. Alright, Salma. I have to go to the shop, please.
And I have to start cooking. But Musa,
Yes?
learning is everywhere, and it is very important for our life also.
It's true. I'm so happy that we always talk about something interesting, not blah blah. Alright, don't break your ribs. Can you tell me two interesting things from our discussion today?
Yes. First, measuring the angle of incidence and the angle of refraction. How about you?
To see the refraction of light with my own eyes through the rectangle glass block and a torch.
Yeah, even me, I was so attracted to the lime in the jug of water as well as the knife.
Alright, Salma. I must hurry to the shop. So, see you next time.
See you, but
What next to me? Please tell me.
please don't forget to repeat that fantastic experiment.
All right, we were together in your discussion, and I'm so happy. Hopefully, our dear listeners have gained a lot through your discussion. Now, here are the questions about the topic for further discussion. What do you understand by the term reflective incidence? What do you understand by the term reflective incidence? Describe the concept of the reflection of light. Describe the concept of the reflection of light. Here is the end of this program, but you are so welcomed in the next program. So, until next time, bye-bye.
Happy, 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 happy. Radio class. Happy, 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 happy. Happy, happy, happy. Radio class. Happy, 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 happy.
Yeah. You can be a pilot, you can be a doctor, you can be a soldier, you can be a lawyer.
If you believe you can, if you start hard you win. If you believe you can, if you start hard you win. Let's win together, 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 together. Let's win together, 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 together. Happy, 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 happy. Radio class. Happy, 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 happy. Happy, happy, happy. Radio class. Happy, 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 happy.
You can be a good father, a good mother, a good leader. You can be a good father, a good mother, a good leader.
Let's win together.